Meow. Welcome to this great courses lecture on when the earth shakes and opens. This is the back half of the lecture where we talk about volcanoes and karst topography.
Both earthquakes and volcanoes are likely to occur along the boundaries of the Earth's plates, but for volcanoes, as I've said, the Pacific Ring of Fire is particularly active. There are also some locations, Hawaii is a good example, of volcanoes that occur in the middle of a plate.
This is a map of known volcanic areas around the earth. Volcanoes can actually happen anywhere on the earth, so that's something you should be aware of. But one of the things I would suggest you do is, if you actually live in any of the red areas, is you move to an area that's not red. If you live in a red area, expect frequent and constant eruptions happening around the red areas, but not necessarily where you are. And the ideal time to move is before a major eruption happens.
Different volcanoes behave differently. In some cases, the liquid rock, called magma before it reaches the Earth's surface and lava afterwards, flows gently down the slope of a volcano. It's still quite dangerous, and material including gas, ash, and rock can be thrown a considerable distance, but the eruption is not a violent eruption. In other cases, the volcano erupts and does explode violently, throwing a shower of ash, gases, lava, rock, and other materials into the sky. This was the case with Mount St. Helens, a volcano in Washington state that erupted in 1980. All volcanoes are dangerous. Lava can flow at temperatures exceeding 2,000 degrees Fahrenheit. Volcanoes can produce a variety of mass movements such as mud flows, also known as lahars. Precipitation or snow and ice melt from the volcano's heat can wash away ash or other materials on the slope, sending it downhill in a rapid and destructive flow. Pyroclastic flows are superheated clouds of ash and gases approaching 2,000 degrees Fahrenheit that can roll down the volcano at hundreds of miles per hour. This is what devastated the Italian cities of Pompeii and Herculaneum in the year 79 CE, killing those who were in the cities and burying them in ash. It was 1700 before those cities were rediscovered and excavations began, with archaeological work continuing even now. Separate from pyroclastic flows, ash and gases may be expelled high into the air, with ash falling onto a wide area and gases impacting climatic conditions. For persons who are in the vicinity, this may cause respiratory distress. This can also cause climatic impacts. In 1883, the Indonesian volcano Krakatoa erupted, showering materials over hundreds of thousands of square miles.
So it's no surprise that these very rare but devastating eruptions that occur, despite the fact most eruptions are small and aren't that devastating, but when the big ones hit, it captures the common imagination. And volcano disaster, earthquake disaster is a common trope, both online and also in media.
Gases altered color perceptions of the sky, led to temporarily cooler climates by blocking sunlight, and ultimately returned to Earth as acid rain. And sometimes, toxic gases may unexpectedly be emitted by a volcano with deadly effects. A tragic instance occurred in 1986 in Cameroon's Lake Nyos, a lake in the crater of a volcano. Carbon dioxide accumulated in the lake and was released, flowing down the mountain for as far as 15 miles, killing more than 1,700 persons and numerous animals and livestock.
Praxis Pepper kindly put up a nice mini-series on carbon dioxide plume that comes out of a capturing technology in a lake and actually kills a lot of people, and there's heroes and people die and there's prepping issues involved in it. Quite a great series actually, but I will say that it is actually attacking carbon capture technology, so I don't necessarily think that's the way to go. You're much more likely to experience this sort of a thing from natural occurring carbon dioxide blooms.
Ipso facto, ergo sum, the assistant's assistant.
Such a meager existence.
Especially when all we're doing is confirming that there will never be an earthquake in this valley.
Never?
Ever.
Well, I'm just here for the paycheck, and besides, I'm thinking of becoming a singer. What do you think?
No!
Is this?
This is ironic.
Are you okay?
Damn it! Damn it!
The United States Geological Survey monitors volcanic conditions in its Volcano Hazards Program. Volcanoes are ranked on a scale from normal to advisory to watch to warning, with a warning being the most severe indicator that danger is likely. The system notes differences between dangers to persons on the ground and to aviation. This is important because the emission of volcanic ash can pose a significant hazard to aircraft. One dramatic example was 1982's British Airways Flight 9, a Boeing 747 that encountered volcanic ash from Mount Galunggung in Indonesia. I can only imagine, and hope I never experience, being on an aircraft and hearing what the captain announced to the cabin that night. And this is his quote. "This is your captain speaking. We have a small problem. All 4 engines have stopped. We are all doing our damnedest to get them going again. I trust you're not in too much distress."
Whatever the issue is, panic never helps, but depending on the size and type of the volcanic eruption, depending on wind direction of the volcanic eruption, soil and water over a large area could be destroyed for a period of a year to 2 to 3 years. So that is something you want to be thinking about.
Fortunately, the aircraft landed safely, but the engines had been significantly damaged, and the windshield in the cockpit had essentially been sandblasted and rendered useless. So how do you prepare for a volcano?
Yes, how?
There's not much you can do, honestly, other than monitoring conditions, and, this is key, if told to evacuate, do so.
The United States of America's CDC department actually has some great steps to take for any disaster where air and or water quality in the local area might be very, very suspect for a period of time. And it's well worth looking at some of these steps and actually thinking how likely it is that you'd be able to implement them if you needed to. Now, I put the link in the description, but I really do hope that everybody watching this has a supply of N95 masks at this point. If you don't, I really have to question why you're even watching any type of preparedness video.
One truth that's important to recognize is that you don't have to be on top of or at the bottom of the volcano for it to pose deadly effects. When Mount St. Helens erupted in 1980, there were lahars and flash floods, pyroclastic flows, ashfall, and a blast zone that leveled trees for miles. These impacts even crossed ridgelines some distance away from the mountain. Entire ecosystems had to recover, and 57 deaths were confirmed. In the aftermath of the 1980 eruption, criticism was leveled about the identification of the danger zone. For instance, investigative journalist Steve Olson reports that only 3 of the deaths occurred within the mandatory evacuation area. And of those, 2 were persons who had been issued a permit to stay to conduct scientific study.
So basically about St. Helens, the size of the eruption did shock and surprise everybody, but the official evacuation zone, because they knew it might be about to erupt, actually meant that I think out of the 54 or 57 people who actually died directly as a result of the explosion, only 3 of them were actually inside the area they'd been told to leave. So almost everybody who died was actually outside of the evacuation zone. Rivers, mountains, everything. In a major eruption, massive waterfall, massive mudslides, massive blast waves, and in fact can be massive flame and heat. So if there's a chance that it might erupt, you want to evacuate, preferably upwind, and you want to evacuate a long way. Don't just evacuate when you're told to and for the distance you're told to.
But only 5 miles inside the red zone on the mountain, we were informed via 2-way radio that St. Helens was acting up again. What's the situation anyway?
It's just on alert right now. They had some seismic tremors up there, so
we're going out.
Going out.
Okay, we'll follow you.
All right.
Work crews wasted no time in responding to the evacuation order. A veritable stream of log trucks, pickups, and crew buses hurried along Route 504, the highway buried and torn in many places by last May's big mud flows. One logger declared, all they said was thumbs up, and that means we get out of there. So we took off. Another said it's getting to be a common thing to hightail it out of the red zone.
It was not just one eruption, but a series of eruptions that continued during the night.
I think it's a golden rule for me. If I'm told by my local council, Huples, you need to evacuate 5 miles, I'm going to go 50. I think that's kind of important. I think that's something we should be thinking about. Having evacuated a considerable distance, you can always come back. If you don't evacuate far enough, you might die.
Volcanoes are devastating, but there is some advance warning, and knowledge of impacts and the scope of evacuations has increased over time. So again, the best I can say for volcano preparedness is to monitor news, watch the warning conditions, listen to instructions from emergency managers or government officials, and be prepared to take your go kit, important records, your family, your pets, and leave the area if instructed to do so.
Very rarely do I really disagree with the professor, but I really disagree with him here. If you're watching this and you live, and I know I have at least one subscriber, I did have a subscriber, who lives literally on the slopes of Etna, near Naples in Italy, that's constantly having minor eruptions, you need to sell, and you need to move, and you need to do it now. Waiting for it to erupt will not do anything for your property values, and is a really dangerous thing. Just because it hasn't erupted for a period of years or in human lifetime doesn't mean it won't erupt again. In fact, it makes it more likely that it will.
The final geological impact that I'd like to discuss today is separate from earthquakes and volcanoes. While earthquakes and volcanoes are events shaped by the large-scale forces of plate tectonics and the geology of the Earth's crust, karst topography is a smaller-scale geologic phenomenon, but it can also be deadly. Awareness is really the key here. Karst topography refers to the presence of water-soluble rock beneath the ground, often limestone. The water can in turn dissolve the rock, especially if the water has acidic properties. If this type of rock and karst features are present, then not much can change that. But here's the hazard, and where awareness of its risks is important. If rock beneath the ground is dissolved, then what happens to the ground above it? The short answer is that it can subside or sink. Sometimes this happens gradually. For instance, water may filter down to the rock, or soil may spill down into crevices in the rock, and ground level may slowly and gently become depressed. Of course, this is detrimental to any structures that are built above, as foundations may become misaligned or structures may shear. In fact, the United States Geological Survey estimates damages of $300 million per year, a figure they suggest is probably an underestimate of actual costs. The more dangerous and sometimes deadly damages are when the ground doesn't just subside, but collapses into an open sinkhole. This can occur when a cavern exists within the rock and the ceiling of the cavern can no longer support the ground above. When structures are built on top of this type of cavern, they add to the weight and may create additional pressure that leads to a sinkhole opening. When a cavern collapses, it's sudden and dramatic. A sinkhole in Kentucky made news in 2014 when it opened beneath the National Corvette Museum, taking 8 of the museum's cars with it.
Karst topography in terms of threats is absolutely localized and minor. Yes, 1 or 2 people a year might fall into sinkholes while they're sleeping and die, and it's tragic. But realistically speaking, if you're buying a home in a new area, you want to get hold of some proper maps and proper information and look for limestone and sand deposits underneath the land, because they can all be eroded by chemical reactions and or washed away by water. So you want to think about the topography of the land. The actual is not just on the surface what you can see and feel, but what's actually going on underneath.
But it's not just property damage. While rare, injury and death can occur. In 2013, a sinkhole opened suddenly beneath a Florida home, causing part of the home to collapse into it. The body of the resident, who was asleep at the time, was never recovered, despite the search efforts of rescuers.
I love narratives, but how in any way is this story helpful to help people prevent disaster and to mitigate the effects of disaster? There's nothing much here for us other than, ooh.
Sinkholes are unpredictable in terms of when they will open and how large they will become. In 2017, another Florida sinkhole opened that continued to grow to over 260 feet, resulting in the destruction of 7 homes.
I mean, let's face it, this house falls into a sinkhole. This is awful. This is an absolute total disaster for me. But somebody who lives 50 feet or 100 feet away, other than maybe property values, is utterly unaffected. Life utterly goes on without any real effects. So this is a really tiny area here. I would have been happy if you'd spent more of the lecture talking about earthquakes and the effects of rivers reversing direction and the ongoing effects from earthquakes in terms of environmental change in soil substructure. I think that's kind of more important. Like when we pull all the water out of the ground in the Midwest and out of the aquifers and then let it evaporate into the air, which causes climate change, and also give it to people like Canada by sending vegetables to us. What happens when you remove that amount of water from these aquifers? What's going to happen over time to the surface. There's already significant dropping of surface in California and the Midwest. At some point that dropping might become quite serious, and it'll be much more environmentally impactful over a wider area than little sinkholes that we're used to having.
There are geological markers that signal areas with karst topography that could be at risk for sinkholes, and some professional geologists make this their area of study.
However, it's 2022 now, not 2018 when this video was made, and you can easily go online and you can easily find out in most parts of the world if you're at risk from karst topography. Even if you're at risk, over geological time this is a factor, but over lifetime of human beings it's not really a factor. It's something to take into effect, that you want to be actually aware of this, but there's not really a heck of a lot you can do other than sell a move. I think you're more likely to be hit by an aeroplane in your sleep and killed that way than you are ever going to fall into a sinkhole and die, so I wouldn't particularly personally worry about this. One thing I will say though, when you do go online and look at these maps are not accurate. Ground conditions underground changes over time, as does water conditions, so it's not necessarily because you're not in one of the areas that says it's at risk from karst topography, you might actually still be at risk from karst topography.
Ground penetrating radar technologies can help to assess the risk at specific locations, but that risk is dynamic, changing over time as water flow, subsidence, construction, and erosion continue. Sinkholes, once opened, can be repaired, which generally involves filling them in, but even with this, they can reopen again in the future.
What you really don't want to do is buy a home around any reclaimed sinkhole site, really, you don't. But one of the other things you might want to think about, my area is actually quite known for mining in the past 150, 200 years ago, is are you actually on a mine site? Mines actually are holes that we dig underground that over time can collapse. When the hole collapses underground, the surface drops. So you might want to think about that if you live in a mining area now or a mining area in the past.
Different jurisdictions vary, but you may be able to learn about the presence of karst topography and the risk of subsidence and sinkholes from agencies such as emergency management offices, which monitor local risks and hazards, planning commissions, which may assemble a jurisdiction's hazard mitigation plan, natural resource or geological agencies, or others. A national level starting point for karst issues, as well as earthquakes and volcanoes, is the United States Geological Survey, which provides useful information. If a sinkhole does open in your area, as always, consider safety first. As with earthquakes, there may be downed power lines, broken gas lines, broken glass, damaged roads, and unstable structures. You may consider consulting with engineering and geological specialists to see if your property is at risk. If a sinkhole opens or subsidence occurs, it is certainly advisable to consult with professionals on next steps. We often take the solid ground beneath our feet for granted. As it turns out, that ground may not be as solid as we believe. Risks may occur when the ground shakes, when molten rock finds a path to the surface, and when solid rock dissolves. The Earth is truly dynamic, which has created many picturesque and unique landscapes, while also prompting us to reflect on the natural hazards that can affect us all in the delicate balance that is geology. Until next time, be safe.
Indeed. Next Friday, we have the lecture on hurricanes, or hurricanos as they say in Puerto Rico, and storms and other storms, which should be fascinating, shouldn't it? Anyway, stay tuned for that next Friday. But what I would ask you to do with this set of videos is watch them all, take notes if necessary, by the old-fashioned methods or the little box if you're addicted to boxes, the electronics, and think about what you're watching, think about what you might need to do where you live and work and play, and think about and discuss with others if you can what actions you should take, and then act. That's critical here. Preparedness without acting is fantasy. Preparedness without doing things is a waste of time. It actually, I would rather be blissfully, happily unaware, living above a forming sinkhole and then die in my sleep, than to have prepared for the sinkhole, figured out that the sinkhole's there, made all my house strong and earthquake proof inside in case there was a slight drop in the ground, and then it collapses. I don't know. I'd move, act, do something categorically the best you can do and afford to deal with the possible threat. And threats have to be significant. So I'm probably going to edit most of that. Have a great week, and Kitty is now going to do some yoga. Bye. This is a Wolfie Terrier and a Marmalade Cat production 2022. Enjoying the sunlight. Wolfie, Wolfie. Wolfie, it's minus 20 centigrade outside. Do you want to go for a walk?